Hi class! Today we are going to learn about trigonometry. The learning target for today is that we will be able to use the sine, cosine, and tangent ratios to find lengths and angles in triangles. Now that learning target will pretty much be covered in class. This video is just going to be over the basics of sine, cosine, and tangent. So first let's start with a quick review. How do you find the third side of a right triangle when you already know two sides? Well, if you're only missing one side in a right triangle, you can always use the Pythagorean theorem to find that third side. A squared plus b squared equals c squared. Now let's talk about trigonometry. It comes from the Greek word for triangle measurement. It deals with right triangles. They have to be right to use the sine, cosine, and tangent ratios. And we'll start by looking at the ratios of sides. So remember, ratios is a comparison of two numbers. We will be writing all of our ratios as fractions. So let's look at a right triangle. Which side is the hypotenuse? Well, the hypotenuse is always across from that right angle. What leg is opposite of angle B? So you look at angle B and you look opposite of angle B, and there's our opposite side. And what leg is adjacent to angle B? So adjacent means next to. It's also the only side that's left in this triangle, and you can see that side CB is next to angle B, so that's the adjacent side. We will be using the vocabulary of hypotenuse, opposite, and adjacent throughout this whole lesson and in class. You could also write these out as answers, like the hypotenuse is line segment AB, the leg opposite is line segment AC, and the leg adjacent is line segment CB. So we are going to use SOHCAHTOA to remember our sine, cosine, and tangent ratios. So I just said we're going to be using opposite, adjacent, and hypotenuse when we're talking about all of these. So in SOHCAHTOA, the S stands for sine, O stands for opposite, H stands for hypotenuse. Cosine, the C stands for cosine, A, adjacent, H, hypotenuse. T stands for tangent, O, opposite, A, adjacent. It's very, very, very important that you remember SOHCAHTOA. It'll really help you out with your trig ratios. So the sine ratio, in a right triangle, the ratio of the leg opposite to an angle to the hypotenuse is a constant. This is called the sine ratio. So sine is opposite over hypotenuse. Sine is opposite over hypotenuse. That's why we call it SO. So in this triangle, we're going to let AC equal 5, AB equal 3, and BC equal 4. We need to find the sine of angle A. So looking at angle A, we need to write down the side opposite, which is 4, over the hypotenuse, which is 5. So the sine ratio is 4 over 5, or 4 to 5. The sine of C. Here's angle C. The side opposite is 3, and the hypotenuse is 5. So the sine of C is 3/5. Now let's look at the cosine ratio. In a right triangle, the ratio of a leg adjacent to an angle to the hypotenuse is a constant. So cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So we're going to look at the same triangle we were before, but this time we're going to calculate the cosine ratios. So the cosine of A is going to be the side opposite over, not the side opposite, sorry, the side adjacent over the hypotenuse, which would be 3/5. Then for the cosine of C, the side adjacent is 4 over the hypotenuse, which is 5. So that's 4/5. Finally, we're going to look at the tangent ratio. In a right triangle, the ratio of the leg opposite an angle to the leg adjacent to the same angle is a constant. This is called the tangent ratio. We will never use the hypotenuse when we're talking about tangent, because the hypotenuse is never the opposite side or the adjacent side. It's always the hypotenuse. So tangent is equal to opposite over adjacent. Look up at your TOA. Tangent is equal to opposite over adjacent. So looking at the same triangle that we've been looking at for the past 2 examples, if you're looking at angle A, to find the tangent, you look at the side opposite, that's 4, over the side adjacent, which is 3. So the tangent of A is 4/3. Now look at angle C. The side adjacent is 4, the side opposite is 3. So the tangent of C is, that should be, I messed up on that, I'm sorry, the side opposite and the side adjacent. So opposite over adjacent would be 3/4. I was going too fast, I apologize about that. So let's practice. We're going to write the sine, cosine, and tangent ratios for angle T. So in both of these triangles, we're actually missing a side. So you would first need to complete the Pythagorean theorem to find that that missing side is 5. In this one, we're missing a side right here. I would do the Pythagorean theorem, 8 squared plus x squared equals 10 squared, and we would find that that side is 6. The reason I didn't do the Pythagorean theorem is because these are actually triples, so you could actually find the missing side by using a Pythagorean triple. So we first need to find the sine of t. Well, sine is opposite over hypotenuse. Remember the sine is opposite over hypotenuse. So the sine of t would be 12 over 13. The cosine of t, that's going to be adjacent over hypotenuse, so that's going to be 5 over 13. And then the tangent of t is opposite over adjacent, so that's going to be 12/5. Now for this triangle, the sine of t is opposite over hypotenuse. That's 8 over 10, which you need to simplify to 4/5. You have to simplify your ratios. Now let's do the cosine of t. That's going to be adjacent over hypotenuse, which is 6 over 10. That simplifies to 3/5. And then the tangent is opposite over adjacent. That's 8 over 6, which simplifies to 4/3. That's all for today. If you are confused right now, please go back and re-watch the sine, cosine, and tangent ratios from this video. You absolutely have to know how to find the sine, cosine, and tangent ratios whenever you come into class. Because when you come to class, we're going to be finding missing sides and missing angles. And if you don't have these down, it'll be kind of hard. See you guys later.